Hi, and welcome to this quick video on GeMRTOS, a generic and embedded multiprocessor real-time operating system. In this video, you will learn about the hybrid partition scheduling of the GeMRTOS, which is useful for modern embedded real-time applications. GeMRTOS is a generic, embedded, multiprocessor, real-time, event-driven operating system. Multiprocessor systems enable the implementation of complex applications with multiple subsystems that must communicate with one another. Integrating off-the-shelf libraries and components ready for use in complex applications is one of today's design techniques. Integrating all of these different subsystems in a uniprocessor system can be difficult due to subsystem isolation and processing stress on the system processor. Some multiprocessor systems divide the subsystem set among the system processors. The designer chooses both the tasks assigned to each subsystem and the processor to which the subsystem is assigned. Load balance strategies must be used to avoid overloading some processors while leaving others underloaded. As a result, the implementation is more akin to several uniprocessor systems than a true multiprocessor system. However, there are some approaches in which the operating system chooses the subsystem tasks as well as the processor to execute them. In this approach, known as global scheduling, no processor is idle while tasks are ready to be executed. However, subsystems that require higher processor utilization must share them with the other subsystems in a global scheduling mechanism. GeMRTOS introduced an innovative hybrid partition scheduling based on scheduling lists. Subsystem tasks are assigned to scheduling lists. There can be as many scheduling lists as the designer sees fit. Each scheduling list may be assigned any arbitrary scheduling priority based on the performance requirements desired for the subsystems. Each individual scheduling list may be assigned a fixed priority, earliest deadline first, round robin, or any arbitrary priority discipline. System processors are assigned to scheduling lists. Each scheduling list may have assigned one up to all the system processors. Each system processor may be assigned from one to all the scheduling lists. Furthermore, even if several processors are assigned to a scheduling list, a processor exclusion can be specified to limit the number of concurrent processors executing tasks in that scheduling list. This exclusion can be used to implement load balancing strategies or to address so-called anomalies in real-time multiprocessor systems. As a result, hybrid partition scheduling enables us to separate the design stage from the configuration stage. The design stage specifies the subsystem components based on the functionality to be achieved, whereas the configuration stage determines how the system processors should be used. In this way, hybrid partition scheduling is both flexible and efficient for embedded multiprocessor real-time systems. Each scheduling list has a scheduling priority policy as well as a runtime priority that can change during runtime. Tasks and subsystems in the highest priority scheduling lists have privileges to use the system processors. Processors running the lowest priority tasks and subsystems in the lowest priority scheduling lists tend to be assigned to execute system event-related routines in order to maintain system status. Consequently, operating system overload is greatly reduced for the highest priority tasks and subsystems. GeMRTOS is a groundbreaking innovation for embedded real-time systems. The Intel Neos 2 processor was used in its implementation, but the source code is available for porting to other processor architectures. Information is available on GitHub and the GeMRTOS website. Please contact us at GeMRTOS.com for more information or if you want to join us in contributing to the project. Thank you for your time.